Okay. Hello, good morning, and thanks for your time, your attention. I'm Raúl Aragonés. I will choose all my colleagues in Barcelona, my family, my friends, all the partners of AEinnova, and also the European Commission, that is one of our partners. I'm going to present here how we are transforming the Industry 4.0 into more sustainable and also the smart cities from the perspective of the Internet of Things. Okay? So, first of all, this is AEinnova team. We are 20 guys working day by day with the commitment of the climate change. We are at a scale-up that is a spin-off of the microelectronics department of the Autonomous University of Barcelona. And our mission is to transform the industry that is highly contaminant in their emissions and do it better using the most advanced technology that is fully batteryless. We are harvesting heat of the processes to create clean energy. So our shareholders, maybe, is a summary, is the InnoEnergy, the AET of the European Commission. The European Commission, thanks to the EIC fund, we are now running 4 R&D projects of the European Union in research, in energy, and Internet of Things. The HIT-R from LIFE, the FED Proactive with 11 more partners, the AIC in Dubai 2.0, and one from the Catalonia government, that is the Acció. We have several awards, the most recent in the Hannover Messe, and 2 from the United Nations, one from the UNEC, and the other from the United Nations Global Compact, the ODS 7. We are members of the United Nations Global Compact, from the Greenpeace, the Solar Impulse, the WWF, and among other organizations that works in the same expertise. And well, let's go from blah, blah, blah to the AEinnova. Who we are, what we do.
The era of Industry 4.0 has arrived. The rapid development of the Internet of Things will allow all production processes to reach unimaginable limits, and controlling every part of the operations will be possible. It is estimated that in 2023, there will be 46 billion connected sensors.
This number, 46 billion connected sensors. That means 46 billion IoT devices that are the equipment that process data from the sensor. And that means 46 billion lithium batteries installed in these devices that are replaced frequently from 6 months to 2 years. So from the perspective of the IoT that contributes to reduce the carbon emissions and energy needs, we have 3 big elements to take into account to create the most affordable digital transformation of our society. The first one is how we can power these devices, because there are too much devices and they are growing exponentially. Also, what is the concept of edge computing instead of cloud computing? What is the concept of predictive maintenance instead of corrective or preventive maintenance? And how can combine all together in a solution that is very well interesting for the industry and for the smart cities. The first stage is let's power these devices, okay? For do that, I'm going to summarize all the history of the humanity. This is our Earth, a picture taken from the Apollo 11 in 1975, I think. It has 4.6 million years, 1,000 million years of antiquity. During millions of years has been not suitable for living, has been very hard to live. And we have been adapting to these conditions to become more suitable to live in this environment. Beginning, we began to access to the caves. Also, we domain the fire. Also, we create tools for hunting and for treating all the foods. We invented the wheel. And for example, we began to become artists. Well, we start with agriculture, with the livestock, and during thousands and thousands of years, nothing happened. All the civilization is organized, living in small town villages, and nothing happened. until the 18th century, where appears the steam machine. This concept transformed everything. We are able to increase dramatically our production and our growing. That means the massive fabrication of products and services, the incorporation of the human inside the industry, and also fabricating thousands and millions of things. We are capable to domain everything. Well, that's wonderful. We can do everything. We can manage the chemical, the physics, the electronics. Nothing seems to be wrong. But yes, there is a thing that is wrong. During the last 70 years, the population has multiplied by 4. We have passed from 1950s of 2 billion people to just more than 8 billion people. That means a spectacular growing in foods and energy. This is the last 30 years. We see that we have multiplied by 2 our energy needs, basically in Asia. And these are really what's happening right now. And where the energy comes from, this is a very interesting map for carbon brief. You can identify these are the coal power plants over the globe in 2019. In gray, you can identify those that are being dismantled, that are being closing. The European Union is closing the coal power plants, and also the US, Latin America. But take an instance to watch Asia. It's incredible, the number of power plants that are there. But look the next slide. In pink and purple, there are the new coal power plants they are building, and also the planet for the next year. So it's really amazing. You can go to this direct link, and you will see during the 30 years how has been increasing this number. Just put in the Google carbon brief coal power plants, and you will see this video. So it's incredible. So this implies the certification due to the climate crisis. This is the Pupu Lake in Bolivia. Has disappeared more than 400 species of fish during the last century. The ice melting implies disappearing of islands, coasts, but also the appearance of new disease. You know, when the ice is melting, you have a lot of viruses and bacteria frozen in this ice, and they are appearing. What happened to the COVID? But maybe I think this is a joke compared with what can we find in this ice of 20,000 years. So pay attention about this. And also the change on the currents of the seas in the Arctic and the Atlantic and the Pacific seas. And why not? 2019, these fires in Australia that burns more area than Portugal. This is a consequence of our acting. So we need energy to live, is obvious. But these sensors will allow us to transform our society. It's real. We cannot change that. To power them, we need batteries. But these batteries are charged in those countries. So these batteries are charged by coal. These are reality. And where these batteries are manufactured?
The entire life cycle of lithium batteries is extremely harmful for the environment. The manufacturing process of lithium batteries requires a lot of energy and water. In the process, high amounts of pollutants are emitted both to the Earth's surface and to the atmosphere. Despite of having the option to recycle, it is not economically viable for companies.
So this other number, just less than the 5% of the lithium batteries are recycled. This is the number, okay? Maybe the plan for the electric cars is different because they are big equipments and they're easy to dismantle them and to recycle the parts. But these kind of batteries are not recycled right now. And the plans are tremendous because there is not a clear plan to force people to recycle all the batteries of the devices, for my smartwatch, for my mobile phone, for everything. So why not to make the most sustainable IoT device and power them, removing the battery and power them with renewable and alternative energies. This is our proposal. Well, a simple concept. We change heat by electricity. This is our knowledge. We have experience in this. So converting waste heat into clean power that can give energy to a spread of sensors in the market. But this technology is not new. We are not inventing the rule and the wheel. This technology comes from the space. From 1977, that was launched the first spacecraft, the Voyager spacecraft, more than 63 deep space exploration missions has been launched fully powered by heat. In this case, the heat comes from a plutonium heat source. So they have a plutonium pile that generates heat, 1,000 degrees, and they harvest the heat of this plutonium source, and they create with semiconductors, that it's called Peltier cells, they create clean energy. You can see at your left the radioisotope thermoelectric generator. You can see here what is the equipment. This inside this equipment, that this device is the plutonium, that is in red. Surrounding this, you have, in this case, okay, in this part, we have the thermoelectrical units that surrounds this heat source and creates clean energy from this heat source. This equipment, from the scientists, installed this device in the Voyager spacecraft in 1977. But right now, also all these space missions in Mars are fully powered by heat. They do not wear solar PV panels. So the new Perseverance, the Curiosity, the Proximity, all of them are fully powered by heat. Also the scientists installing in the bottom of the equipment the device. So, coming back to the Earth, to our European Union, that 21% of the energy needs in the European Union is lost in form of this waste heat. The fifth part of our energy is lost in form of heat. This is the number. So why not to convert this heat into clean energy? This is the first approach. We have a project with the European Commission called LIFE, HEAT-R, when this equipment installed in SEAT Volkswagen in Barcelona in 2016 is the first approach of harvesting heat from a chimney. We install a ring with 12 waste heat converters that takes this heat using Peltier cells and our electronics, create negative carbon energy that is injected into the grid of the company. Here we have other projects in Torres, Distiller, Goma Camps, Celsa, and Molins, several high-demanding industries from cement, paper, oil and gas, also wine, also chemical. Look how it behaves. This is the equipment that installs in a section of a chimney. It has similar similarities with the Voyager spacecraft converter, several similarities. So here passes the gases that are heat gases, and we extract the energy from this heat, and we create energy. But why not also to power battery-less sensors? And like Industry 4.0 is touching in the kernel for ODS, I think this is the best way to begin. Our approach consists of three elements: a thermoelectric generator that converts heat into electricity, that gives energy to a sensor, in this case vibration sensor or temperature sensor, a long-range wireless IoT device that sends it to the cloud. This is the approach.
This in Dubai demonstration,
you see how it works?
You can see how the technology works. Initially, an 80 degrees pipeline heat source delivers energy to the AEinnova thermoelectric converter, powering the wireless long-range edge computing IoT device that reads data from a 3-axis vibration sensor. Just attached a rotative machine, in this case a motor with danger vibrations. Vibrations are monitored in Davis, an advanced web-based responsive cloud computing analytic tool, fully developed by our IT engineering department. Davis comes with powerful graphic engines, reports, alarms, analytics, and machine learning capabilities with predictive maintenance algorithms.
So This is a battery-less system with no batteries forever. This is the principle. This equipment is a thermoelectric unit that creates energy from heat. You just attach it to any hot surface at least 50 degrees. This is metallic. No, has no magnet. It's a magnet. Okay, it doesn't work here. So it has a magnetic. We can attach it. You will see how we attach to the heat sources. You attach it, and this is the equivalent to a battery. So it generates constant energy source to power our IoT or any IoT device. Let me see. This is the first approach installed in Sacyr Valoriza in Spain. It's a highly compromised company with a circular economy and sustainable growth. This is a plant that recycles wheels. They transform wheels into rubber for the kids' garden, for the athletic tracks, for ecological asphalt. Okay? So in this case, in this Rasper, this machine, we can identify two thermoelectric devices, two sensors, vibration and temperature sensor, and the IoT. In this case, these equipment are powered by the friction, of the knives of the cutters with the wheel. So these frictions generates heat, and this equipment captures the heat and powers this IoT device and sends data using a long-range wireless protocol to the cloud. The same approach in Goma Camps, the oldest paper company in the European Union. In this case, they also recycle paper. So we are going to harvest the heat of a dryer, of a paper dryer. We will install the thermoelectric device in one of the parts of the dryer. We'll install the IoT device and the sensor, and voila, this equipment is fully batteryless and sends data, in this case, at 40 meters. But this protocol gives access to up to 2 kilometers of link of connection. Another project in a Leches plant in Ferrovial. This is a plant that, from the garbage, they generate biogas. They burn the biogas. And with this heat of burning biogas to create energy, we harvest the heat of several parts of the facility and monitor vibrations in this plant. Also in Ercros, a chemical plant, an intermediate chemical plant located in Barcelona. They're also highly compromised with the environment. And we are harvesting the heat of a steam pipeline. And this is a very interesting photo because we identify the thermoelectric generator, the IoT device, and the vibration sensor attached to the motor. A fully battery system and maintenance-free system. But now we are improving new approaches because these just are always solutions for the Industry 4.0. What about the smart cities? This project was launched last year in the subway of Barcelona. You can see here the typical ventilator fans that are installed in the ceilings of the top of this ventilator. In a typical subway, they have more or less 1,000 of these ventilators to guarantee the quality of the air. They are installed in mining, underground, marine ventilation, wind turbines. But these equipments right now are not real-time monitored. So there is an employee that takes his train, his equipment, and with a manual monitor, touches the motor and takes note in a sheet. And this process repeats every 15 days. But what happens? Sometimes, the year before, in a North subway company, appears this. At 200 kilograms, ventilator fan falls off from the ceiling. And it doesn't cause an accident because it happens at 3 o'clock in the morning. But imagine this at 11 o'clock in the morning with all the full trains. What is our approach? To create a battery-less, vibration sensor, fully powered by wind. And this is the equipment. You can identify 3 elements. The turbine. So the blades of the ventilator move the blades of our microturbine that powers the IoT and the sensor all in one and sends data practically in real time. Every minute, we have the vibration measurement of this motor, once every minute, instead of once every 2 weeks. And this is an approach. Our first pilot, you install it in the ventilator fan, and just the airflow generates energy that powers the IoT device and the vibration sensor, and sends data in real time. No battery, no maintenance. Another approach is for Cementos Molins, another different industry. Maybe you know, but these companies, like Cementos Molins, has hundreds and thousands of silos full of cement for basically for the buildings, okay? And, or for example, for the civil infrastructures. And these equipments that also are equivalent to grain silos, to sand silos, are not really now, are not monitored. They don't know really what is the level of filling. That means they have a lot of trucks doing invalid routes because maybe it is at 80% and you are going to refill it. Maybe it's at 5% and you don't refill it. So it's a question of managing the flows. We have created another solution fully powered by solar PV. What is this? This is the first battery-less, fully powered by PV, volume monitor that measures volumes in real time, fully powered by PV panels, and sends data using 5G, the narrowband IoT band. It incorporates basically two kinds of sensors. We're testing right now the sensors. One is a LiDAR, like the autonomous cars, and the other is a distance sensor, ultrasound sensor. And while sending in real time to our customer, so to our, these are proof of concept, to our candidate of customer, the solution to organize trucks of refilling depending on the level of filling. This is the equipment. We install this into a rope, into a roof of the silo, incorporates the SIM card, and it's fully powered by, there is no alternative energy sources, right? And sends it to the cloud. So if we go down and analyze what is the environmental impact of 10,000 devices powered by battery and 10,000 devices powered by alternative energy sources like this kind, we're passing from 100,000 tons of carbon emissions to just 1,000, from 17,000 decameters cubic of water to just 180 decameters cubic of water, from 19 gigawatts of energy to manufacture the battery and to charge the battery to just 0.24, and from 5,000 gigajoules of heat to just 5 joules. So the reduction, the overall reduction, is more than 98% of impact, environmental impact reduction. You have seen the equipment. It's also available for installing in explosive environments like oil and gas, like iron and steel. We need at least 50 degrees Celsius to operate. Let me introduce this project. It's a very big European project where AEinnova is the integrator, is a FED proactive from the European Union. We have 11 partners. From my point of view, one of the best partners in the European Union related to iotronics and energy. From the IREC, the Institut de Recerca d'Energia de Catalunya, the Imperial College of London, the Centre National de Recherche Scientifique of France, the CSIC from Spain, and several other companies in the European Union working together to create, in 3 years, the smallest IoT in the world, fully powered by solar PV and heat. In the size of one poker die, we'll have everything, sensor, IoT, and also energy production. This is the concept of a smart dust. Another project that is working right now is the integration of the IoT and the thermoelectrics in just one device. This is a project in Dubai 2.0 from the IAC, the European Innovation Council. And this project will end this year, and it's the same approach. I harvest the heat of a pipeline, I convert heat into electricity in this device that powers the IoT device, and finally, I'm able to monitor vibrations, temperature, and so on. And for the last 2 points, edge computing and predictive maintenance, just to introduce, predictive maintenance reduces energy because I can determine the life of the machine, and this implies energy reduction. But also this implies that we're able to establish if this machine can last more hours, and that means less spare parts. That means less raw materials, and that means less environmental impact. So the reactive and the predictive maintenance reduces the environmental impact. So we're incorporating in these devices predictive maintenance. And also the important concept, the edge computing. Edge computing means that you are able to compute all data inside the device, not into the cloud. The cloud is the guilty of the 9% of the global energy consumption, and the guilty of the 9% of the pollution in the air. So if we are able to process all the data inside the device, we can reduce the computation in the cloud because we are doing computation in the device, and this is called edge computing. Battery-based systems cannot do that because computation means less lasting of the battery. We can do that if we are using renewable energies because we have a continuous energy source in the equipment.
Now is the time. Join us.
Okay, thank you very much for your time and for your attention, okay? It's a pleasure to meet you here. And I want to give a special thanks to the Fondo Repsol de Emprendedores that committing us in 2016 and from the first 2 years. InnoEnergy, the European Commission, that is our partner, and also to the COP26 for inviting me to attend here. Thank you very much. And we have 5 minutes of Q&A. So if there is anybody in the internet connected that wants to make a question, or here in the stage. Don't get panicked, you can ask if you want. You. Can you send, yes, there is a microphone here.
Hi, yeah. I thought it was a really interesting presentation, really interesting sort of technology, and I'm always keen to see new technologies put forward. I come from an engineering background myself.
Okay.
What do you see as the next stage? I'm always interested in, we've got a technology, how do we implement it further? How do we really gain the true, what you believe is the effectiveness of this technology and what it can bring to the planet?
Okay, thank you. So it's a very interesting question. It's not easy because I know it's a scale-up of 7 years old, thanks to being recently invested by the EIC fund from the European Commission. We have plans to make this grow globally. It's not easy to become a new player in the automation sector because all the lobbies, like Siemens, like Robert Bosch, like Schneider Electric, like Emerson, has coped all the market. And when a guy that says, oh, I want to give a space with a new solution, new technology, they make us force because they want to maintain their status, okay, in the Industry 4.0. I think from my point of view, we are working in the right way. We have 4 R&D projects right now, testing the solution in several customers, in the energy-intensive industries and also in the smart cities. We have plans to grow in the Germany, also in France and Italy in this 2021, 2022. And we expect, thanks to the European Commission that is part of us, to grow faster and to arrive to the market faster. Because I think this is the right moment to incorporate the solution. The industry is growing. A lot of industries worldwide are transforming to more digital. And this is the time to adopt these kind of solutions, not battery-based solutions. I hope that this technology will penetrate all market. I want to believe that we are able to transform the industry into more sustainable, because there is no other way to do that. And lithium batteries is not the right way, because it requires a lot of resources, are very contaminant from the extraction. You can see extraction from the Argentina, from the triangle of the lithium, and also in the cobalt, that using practically people under slave situations. We can remove this, we can avoid this, and create the most advanced devices using this kind of battery-less systems, fully powered by renewable energies. Okay? You have to approach to the microphone. Thank you.
Thank you very much for your real presentation. My question is regarding the data storage, because it's real-time monitoring and we need the data later on. How are we going to do it?
Okay, so the question is, as well as you can compute data in the device, so I introduced the concept of edge computing. That means the device is able to compute. That means this device can also determine if the value is right or not, if this value gives additional value to you or not. So we only send data if the data is valuable. That means the cloud computing do not compute, but also do not store data that it's really not usable. Right now, the actual equipment takes data, sends it in practically once a day or once every hour, and data can be bad or not, but data is stored and processed. Doing edge computing, we avoid this. So we acquire data, we process the data, and if we see if this data is significant for the customer, we send it. If not, I just send a ping, hey, I'm alive, nothing else. That means there is a cost reduction in the cloud, but also an energy reduction of the cloud, because there is no energy stored for the storing of the data and not energy for the computing of the data. This is a contribution, this is a line of research of people. If you look for edge computing in the market, in the internet, you will see a lot of literature speaking about that. I think it's highly interesting. Thank you for your question. Okay, tell me.
I'm sorry I got here late, so you may have already answered this, but your thermoelectric generator is only producing very small amounts of power just to drive your data system.
Yes.
Is that correct?
So this equipment generates, this is a previous version, but our equipment generates up to 1 watt of power. That means if our devices consumes 0.1 watts of power, we generate more energy than needed. That means it depends also in the temperature. At 50 degrees Celsius, we generate more or less 80, 19 milliwatts. And this growing is exponential up to 150 degrees. So this equipment is able to be used from 50 degrees to 150 degrees Celsius. That means the power increases exponentially. So at 50 degrees, it generates free energy, but it's enough for us. At 150 degrees, it generates 1 watt of power that overpasses all the energy need. Okay? So basically, it's this. We have continuous energy source. In a facility that works 24 hours a day, all the days of the year, like iron and steel, aluminum, ceramics, even, the heat is everywhere. You can generate energy continuously, and you can generate real-time quality data if you need it. Okay?
Thank you.
Thank you for your time, for your question. Okay, time is gone. Do we close the? Okay, so thank you very much for your time. Thank you.